Hello students, how are you? My name is Sudhir Jaiswal. I am going to teach you today the matrix. Okay, here by the definition of matrix, matrix is the arrangement of mn elements. Okay, numbers. You can say that where m represents a number of rows and n represents number of columns. So how do we say this? So it is a matrix A equal to, suppose A is the matrix, it is represented as Aij and order is represented as m cross n. So what we can say that here Aij are the elements of the matrix A. So suppose Aij can be I can be any integer, like any positive integer, like here non-zero. Okay, so I can be, or you can say example here A1 2 can be element of first row and second column. So it is actually by the definition of matrix, if I arrange this in the rows and columns, so here you can say the 1 2 3 4 5 6 7 8 9. So here we have 9 elements in this. Okay, and we are going to arrange this. I'm here arranging this in order 3 cross 3. Okay, why 3 cross 3? It assumes that if you multiply this, you will get the number of elements, total number of elements. So here it is the element of A11 is the element of first row and first column. This is called rows. Okay, R1, R2 second row, R3 third row. If you have R4 fourth row, fifth row, okay, the nth row. Here C1 is the first column, C2 is the second column, C3 is the third column, C4 fourth column, C5 up to Cn or m, you can say that here. So m columns and n rows. So this is represented m cross n. Okay, so m is 3 here, and it is actually a square matrix that you see the square. That means number of rows and number of columns are same here. So here you can represent A12 is the element of first row and second column. A13 is the element of first row and third column. A21 element of second row and first column. A22 element of second row, second column. A23, A31, A32, A33. So by the definition of matrix, it is actually the arrangement of elements. We call it numbers. Okay, in order m cross n. Okay, where m represent number of rows and n represent number of columns. Okay, so where do you see this kind of arrangement? You see in the Excel, MS Excel. So we have different rows and different columns in that. Okay, and in the school we see the sitting arrangement of the students. It has rows and column, and also so you can see the application of matrix everywhere in the real life. So here we are going to do some related question here. Okay, so it is represented in the square bracket, or this, you can say that the circular bracket, like this. If I give an example here, elements are 1 2 3 3 2 1, suppose. So if you want to find the order of this element, this matrix, order of this matrix, so or first so you can say how many rows are there. So here 2 rows R1 and row R2. How many columns are there? 3 columns, C1, C2 and C3. So first you write here, if you want to write order, first you write here number of rows. So 2 rows and how many columns? 3 columns. Okay, so this is m cross n is the order. And if you want to find the number of elements here, how many elements are there in A, so just multiply 2 and 3, 2 into 3, it is 6 elements. There are total 6 elements in matrix A. So now if I give you one more example here, if I B equal to 1 2 3 3 2 1, suppose this. So if you want to find the order of this, so how many rows are there? 1 2 and 3. So write the rows. How many columns? 1 and 2. So order is 2 cross 3. Again it contains how many elements? 6 elements. So okay, either if you can take one more element, one more here element like this, 1 2 3 5 5 9 2. Okay, all right. So 1 2 3. How many rows are there? How many rows? It has one row. Okay, how many columns? 1, C1, C2, C3, C4, C5 and C6. So one row but 6 column you see here. So there are also 6 elements. So, and in this way, if you assume this D as 1 2 3 5 9 2, it contains how many? One column and 6 rows. 1 2 3 4 5 and 6. So what do you write here? First you write rows 6 and column 1. All right. So in this way you represent the matrices. Okay, and in this way you can find the order of matrices. So let's move to the topic here. So we are actually in the matrix representing the elements in order, and orders are rows and column, you know. Okay, now moving to the matrix is only arrangement of, okay, note, a matrix is only the arrangement of numbers, it has no definite value. So matrix is only the arrangement of numbers, it has no definite value. So if it is a matrix, can you find the order of this matrix? Its order, it has only one row and one column. Its order is 1 cross 1. It doesn't mean that it is equal to 7. It does not mean that it is equal to 7. So here it is, you have to note that a matrix is only the arrangement of numbers. It has no definite value. It has no definite value. Okay, keep it in mind. So now we are moving to the question here, and the question is the elements of Aij of 3 cross 3 matrices. That means you have to make this Aij is the matrix whose order is 3 cross 3. You have to make 3 cross 3 matrix here. Okay, and Aij is given here. Rule is 1 by 2 mod of minus 3i plus j. All right, this is, then find the value of A32. You have to find A32. Okay, first you have to find the matrix, then you need to find the A32 question mark. So if you want to find the matrix, so you have to okay, so since it is 3 cross 3 matrix here, you see, so you need to find A11, A12, A13, A21, A22, A23, A31 means third row and first column, A32 third row and second column, A33 third row and third column. So now you have to find all the elements, that means all the elements by applying here the values, that like A11, put the value I as 1 and j as 1. So how would you get? If you put the value here A11, find, so you can write here A11 equal to, what is the 1 by 2? A11 means at the place of I you put here 1, at the place of j you put here 1. All right, so half minus 3 plus 1, it is minus 2. Since mod is here, so you would take the positive value. So it is 1 by 2 into 2, it is 1. So at the place of A11 you write here what? 1. Similarly A12, A13, A12. So at the place of here, place 2. Okay, at the place of I place 2, 1. At the place of j only put 2, so it would be minus 3 plus 2 minus 1, and the answer would be 1 by 2 because you have to take the positive value. So here 1 by 2. Similarly, you can solve each and every value, all right, by putting the value of I and j. This is very easy question. So here at the end they are asking that what is the value of A32. Okay, so you can find here A32. So at the place of I you have to place 3, at the place of j you have to place 2. So 1 by 2 minus 3 into what is I is 3, what is j is 2, all right. So half of minus 9 plus 2 equal to half of minus 7 equal to, you have to take the positive value, so it would be 7 by 2, all right. Let's move to the next question here. The next question is, there is no any next question. I think we have to do the concept types of matrix. So there are many types of matrix. You see the row matrix first, row matrix. So matrix in which you see only one row, I think. Yes, you see only one. That means A is the matrix. Aij are the elements here, and you see only one row, but many columns. For example, 1, 2, 3, 4, 5, 6. How many rows? 6 rows. Sorry, how many columns? 6 columns, but you have only one row. All right, only one row, but how many? 6 columns. C1, C2, C3, similarly. Okay, you know this. Now move to the column matrix. If the column matrix, it has only one column, okay. If the column matrix is like this, like you get here m cross n, means here m cross n, but in the column you get only one column, means m cross n, okay. There are many rows, but only one column, like 1, 2, 3, 4, 5. So it has only one column, but many rows. This is called column matrix. Okay, all right, m cross n. Now third is rectangular matrix. So rectangular means m is not equal to n here, like 1, 2, 3, 3, 2, 1. Suppose this is a matrix, okay. So m cross n, here you cannot take m equal to n, okay. If you take m equal to n, this would become square matrix. So you need not, in square rectangular matrix, m should not be equal to n. That means number of rows should not be equal to number of columns, as you know in the rectangle, okay. So similarly, when you define square matrix, so here arrange 1, 2, 3, okay. So here you see this is square matrix. Here if its order is m cross n, suppose. So here you see m equal to n. That means here you see how many rows? 3 rows and 3 columns. So here m equal to n, 3 cross 3 matrix. Similarly, you can find 1, 2, 2, 1, 2 cross 2 matrix. It has also number of rows and number of columns are equal here. So these are the square matrix. So next, what is this? Null matrix. All the elements in the square null matrix, it is a kind of matrix in which all the elements are 0. So it can be like this, okay. All the elements are 0 here. So this is not necessarily a square matrix, okay. So any null matrix is denoted as this, like big 0, okay. It has order m cross n, maybe, yeah. So just remember it. Diagonal matrix, okay. Diagonal matrix, keep it in mind. Matrix, what is this? Diagonal matrix means you see one thing in the diagonal, like A, B, C, okay, and all elements except diagonal is 0, okay. All the elements except diagonal is 0. So diagonal, in the diagonal you see what? A, B, C are in the diagonal, okay, and except diagonal all the elements are 0 here. So it is called diagonal matrix. And here you can say that A is not equal to B, is not equal to C. They are not equal. And what if they are equal? Then it will become the constant what? Scalar matrix. So scalar matrix, if you want to write scalar matrix, okay. So you can like K, K and K in the diagonal, and except the diagonal all the elements are 0. And here you see the diagonals have same number, okay. Diagonals have same number. So here you can see that this is a kind of square matrix, and and this should be the diagonal matrix and scalar matrix is only applied in square matrix. So in a square matrix, if you see the diagonals, different diagonals, sorry, if you see the diagonals and except diagonals, all the elements are 0. So you can say that this is a diagonal matrix, and if you see the same diagonal here, okay, a diagonal matrix in which all the elements in the diagonals are same, so it is called scalar matrix. And if you like in the diagonal, if you place 1 1 1 in the diagonal, so a diagonal matrix or a square matrix in which in the diagonal there are same element, same number, which is 1, then we can say that it is a identity matrix. Okay, here you see what it is, a kind of square matrix, it is a diagonal matrix, and in the diagonal you see 1. So you can say that it is an identity matrix. Identity matrix is represented as I, so identity matrix. So here A is not equal to B, is not equal to C. Here you see same element in the diagonal, here you see 1 in the diagonal, only 1 in the diagonal. So this is diagonal matrix, this one is scalar, and this one is identity. So you can see the difference and similarities, and what difference in that in these. But similarities is only that all are square matrix. The order is 3 cross 3, 3 cross 3, and here 3 cross 3. So 2 cross 2 is also applicable here. Okay, how? Like if you say here 3 4 3 0 4 2. Okay, sorry. So this is a diagonal matrix. Okay, when you place 3 0 3 0, this is a square matrix of 2 cross 2. This is called scalar matrix. Okay, and if it is 1 0 0 1, this is identity matrix. Okay, so let's move to the diagonal matrix. Unit matrix is clear. Upper triangular matrix, upper triangular. Okay, so upper triangular means the value above diagonal, the elements above diagonal are called upper triangular. Okay, for example, upper triangular, and these are lower triangular. So let's give me the example here. So by the example you will be able to understand this, what is upper triangular and lower triangular. Okay, so here if I say 0 0 0 1 2 3 4 5 6, okay, so it is the diagonal. This is lower triangular. Okay, this is lower triangular matrix, and is it there or not? Yeah, lower triangular or upper triangular. This one is upper triangular. Here see the element in the upper triangular. Okay, and when you see 0 1 2 3 4 5 6 in the diagonal, and these 3 elements are 0 and these are diagonal. Okay, all right, so you call it this one is upper triangular. Yeah, what is this? This one is upper triangular and this one is lower triangular. So lower triangular, what is the difference here? In the upper triangular, you see all elements are here non-negative, non-zero. Okay, here the diagonal and the upper triangular, diagonal and the lower triangular. This is you see when you make a triangle here, like when you join these, you will make a triangle. Okay, what is this? Yeah, I think, yeah, when you join these, you will make a triangle here. So I think now you are able to solve, you able to signify it. This is the upper triangular, this is a lower triangular, isn't it? Yeah, upper triangular, yes, this one is upper triangular. Write it, upper triangular. Okay, matrix, triangular matrix, and this one is lower triangular matrix. It is the only name you have to learn, but we'll use also this concept in the conversion of or finding the inverse of matrix by elementary row operation. Then we talk about the upper triangular and lower triangular. Let's move to the equality of matrix. Okay, equality of matrices. Okay, so here if A equal to Aij, okay, this is the actually matrix which has element, like I have explained you, the elements are A11, A12, A13, A14, any. You have to define the order, okay, and order is M cross N, and B should be Bij, and order is here M cross N. Suppose if the order is something else, then equality is not possible. That means they cannot be equated. So for equality of matrix, their corresponding elements are equal. So you have to, their corresponding elements are equal. So how would you justify it? So here you need to check that whether it has same order or not. Here you see M cross N, here is also M cross N. If you place here N cross P, then there would be problem. So we'll justify this with the example. So their corresponding elements are equal. So what are the corresponding elements? A11 should be equal to A1. A11 of that matrix should be equal to B11 of this matrix. Okay. For example, if equal to here A11, A12, A21, A22, okay, 2 cross 2 matrix, and B equal to here B11, B12, B21 and B22. So it is also 2 cross 2 matrix here. See, you can see that. Now this can be, if they are equal, then A11 would be equal to B11. That means first element of first row and first column would be equal to element of first row and first column of this matrix. Element, suppose, and A21 equal to B21, A21 equal to B21. That means element of second row and first column of this matrix equal to element of second row and first column of this matrix. Okay. So in this way you can say that A equal to B. So we'll use this in the question. Now move to the algebra of matrix. Should we? Now we can move to algebra of matrix. We need to learn, okay, the corresponding elements are equal. So application is important. You need to learn all these things and understand what are these. Now move to the addition of algebra matrix. Addition of matrices. Okay. So suppose matrices A equal to Aij. Okay. It is a matrix. It is A is a matrix which is in order M cross N, and B is the matrix also in order of M cross N. If you want to add these two matrices, then the order should be equal. Okay, the first condition, order should be equal, and corresponding elements will be added with. That means will be added, like if I give example A11, A12, A21, A22, and B is the matrix. This order is 2 cross 2 here. B11, B12, B21 and B22. Order is 2 cross 2. Okay. If you want to add these, the corresponding elements will be added. So A plus B means the corresponding element, like A11 will be added to B11, A11 plus B11, A12 will be added to B12, A12 plus B12, A21 plus B21, okay, and A22 plus B22. The corresponding elements will be added. That means element of first row and first column should be added to the element of first row and first column here. Yes. Okay, I hope you have understood this. So now we have to uh, understand the properties of here. So addition, that addition and subtraction of two matrices. Okay, it is possible. Matrix addition is, can you write, matrix addition is commutative, isn't it? Yes, it is. A plus B equal to B plus A. Yes, you can see, you can do this. A plus B equal to B plus A. Associative, yes, it is associative also. A plus B plus C in the first bracket here, if you place bracket, A plus B plus C, that means you can place here the bracket. Okay, so matrix addition is commutative, matrix addition is associative, and so I can write here commutative, associative. Okay, now third is what? Oh, null matrix. Yeah, okay. Identity matrix. Okay, identity. So yes, additive identity, not identity. Sorry, additive identity exists. Yes, if there is a matrix. Okay, suppose if you add any other matrix with this to get the same matrix A. So what will be the matrix here? The zero matrix. What do you call the big zero? The zero matrix. Here the matrix, zero matrix should have the same order. Okay, so you know this. So zero matrix is called here the additive identity. Okay, now what is additive inverse? Isn't it, is there or not? Okay, additive inverse. Okay, additive inverse. So what is any matrix? What should you added in A to get the identity matrix, which is what? The zero. This is the property of how to get. You should add any other matrix in A in order to get the identity matrix, which is zero matrix, null matrix. So here the negative. So minus A is actually negative of the matrix. The minus A would be the additive inverse. All right, here minus A would be additive inverse. This is the part of the, what do you call, the algebra of matrix, the properties of matrix addition. Okay, now what is the property? Scalar multiplication. Yes, suppose okay, there is property scalar multiplication. Suppose A is the matrix of order m cross n, Aij, and if you want to multiply this matrix by K, suppose Ka, then K times Aij. Okay, then K can be multiplied here in this. Then K will be multiplied with each and every element. Okay, so how? If A is 1, 2, 3, 3, 2, 1, find the order. What the order? How many rows? 1, 2. So write 2 rows. How many columns? 1, 2, 3. 3 columns. Okay, find the number of elements. Multiply this. 6 is the number of elements. If you want to find 3 times A, okay, that means you are multiplying A by any scalar number. So what would happen? 3 will go inside and it will be multiplied by each and every element here. 3 1s are 3, 3 are 6, 3 3s are 9, 3 3s are 9, 3 2s are 6, 3 1s are 3, like this. And order should be here same. Okay, now move to the next part. Now we will do the question, most important part, the question. You guys are waiting for this. Okay, the question is here, question number 1, you can say that 3xz yw equal to x minus 1, 6 and 2w plus 4 z plus w, x plus y and 3. Here the question is find z. Oh my god, find z. Oh, So this is given. Now this is the equation, I think. Yeah, 3 into this matrix order, you see, 2 cross 2, how 1 2 rows 2 columns. Okay, 2 cross 2, 2 rows 2 columns. Okay, 2 cross 2, 2 rows 2 columns. Okay, 2 cross 2. Now you have to solve this. So I have explained you in the matrix scalar multiplication, 3 will go inside and multiply with each and every element. Here 3x, 3y, 3z and 3w. Now add. Okay, in the matrix addition, what do you see? The order should be same. If it is A, it is B, then order should, both the elements should have, both matrices should have same order, and order you see here 2 cross 2 and 2 cross 2. Now the corresponding elements will be added, like x plus 4, all right, x plus 4, this is second element of first row and second column, element of will be added with the second element of second row, for the first row and second column. So 6 will be added with x plus y, again minus 1 will be added with z plus w, and 2w will be added with here 3. All right, now the addition is done. You see here what is the order of this matrix? Here 2 cross 2, 2 rows and 2 columns. Here 2 rows and 2 columns. Now we understand in equality of matrix, the matrix if the matrices are equal, then corresponding elements will be equated. So here you see, and the order are same here, so this matrix can be equated. 3x will be equated with x plus 4. Okay, now 3y will be equated with 6 plus x plus y, 6 plus x plus y. Okay, 3z, the corresponding elements of 3z is minus 1 plus z plus w. 3z is equated with minus 1 plus z plus w, and similarly 3w will be equated with 2w plus 3. 3w will be equated with 2w plus 3. All right, now you need to solve. Okay, 3w minus 2w, w equal to 3 you will get here. Okay, and 3x minus x, x equal 2x will be 4, x will be 4 by 2, you will get 2. Okay, here 3y plus 6 plus, place the value of x here 2 plus y, so it would be 3y minus y, 2y equal to 8, y equal to 4. Okay, you need to find the value of z here, so 3 times z equal to minus 1 plus z. Oh, so transpose z here, minus z equal to minus 1 plus w, 3z minus z, it is 2z. Okay, equal to minus 1 plus w. What is the value of w here? 3. So 2z equal to 3 minus 1 is 2, z would be here 1. All right, either you have to find only the value of z, and you have also found here x and value of x and y. All right, so this was the question. Next, let's move to the next question here. The concept should be okay, scalar multiplication and all. Yeah, we'll move to the next. Multiplication of two matrices. Okay, here the last topic here, multiplication of two matrices. Multiplication. So how would you multiply? Multiplication of two matrices. So suppose here I am giving you 2 1 3 5, okay, and b equal to 5 1 2 7. Okay, what is the concept behind matrix multiplication? If you want to multiply, first you see here the order should be here if you have two matrix, first is A equal to Aij in order m cross n, then second matrix should be Bij. The order should be n cross p, means the last what this represents column. Number of columns of first matrix should be equal to the number of rows of the second matrix. N should be equal to n here. That means this represents number of columns of matrix A, and this represents number of rows of matrix B. Both should be equal. Okay, and when you multiply these, you will get, suppose, Cij after multiplication, and what would you get the order? You will get m cross p. All right, this concept is very important. What, when you multiply this, what is the rest? So you should check that whether n is, that means n is equal to n or not. That means last, this is the column number is equal to row number. Okay, number of rows, number of columns of the first matrix should be equal to the number of rows of the second matrix, and whatever is in the product, you get m cross p. That means whatever you have left, okay, you will get the order m cross p. So let's understand with the example. Here you have, what is the order? 2 rows, 2 columns, 2 cross 2, 2 rows, 2 columns, 2 cross 2. The condition, the column should be equal to the row. Okay, and what would be your product? And your product would be in order 2 cross 2, the left one, the 2 cross 2. Okay, that means you know that you have what, you would make the answer in order 2 cross 2. All right. So now we come to the product. How would we multiply? We first, this is R1, R2, C1, C2. Okay, so row 1 multiply with the column 1 here, C1, C2, R1, R2. Okay, row 1 will be multiplied with column 1. How? 2 5s are, like 2 5s are 10 plus 1 1s are 1, like this. 2 5s are 10, 1 1s are 1. Again, row 1 will be multiplied by column second. How? 2 2s are 4 plus 1 7s are 7. That means how we are multiplying? A11 will be multiplied with B11, and A12 will be multiplied with here B21, second row and first column. Okay, so now let's apply the application on this question. Here this row, here row 2 will multiply with column 1, like this. 3 5s are 15 plus 5 1s are 5. Okay, now 3 2s are 6 plus 5 7s are 35. Okay, if I want to put the notation, I can also write it for you if you want. Have done what? 2 5s are 10, 2 into 5 plus 1 1s are 1. Okay, you need to learn this. Row first will multiply with column first. Now row first again multiply with column second. You will paste here. Okay, 2 2s are 4. Okay, and we place the elements in row 1. Okay, row 1. Yeah, 2 2s are 4, 1 7s are 7. So 2 into 2 plus 1 into 7. You can write it like this for better understanding. 3 5s are 15, 3 into 5, like row 2 multiplied with column first. 3 5s are 15 plus 5 1s are 5. Okay, here now row 2 will be multiplied with column second. Here you will paste the value. 3 2s are 6, 3 into 2 plus 5 7s are 35, 5 into 7. The answer would be 10 plus 1, 15 plus 25, here 4 plus 7, here 6 plus 35, okay, and 11, 40, 11, this is 41, all right. It's 40 or not? I think it is wrong or not. It is 15 and 5 ones are 5. Yeah, I have put here wrong, I think. I have solved this, but 3 5s are 15 and 5 ones are 5. Yeah, yes. 3 5s are 15 and 5 5s are I have written here. 3 5s are 15, 3 into 5 and 5 ones are 5, okay. So we place here 5, it would be 20. So you have to keep this in mind, the calculation would be strong. Okay, now move to the next question. And the question is, okay, let's move on the properties, okay, of matrix multiplication is what? Is not commutative. That means AB would not be equal to BA. Although it is associative, A, B, C means here can do also A, B, C. It is associative, okay. The matrix multiplication is not commutative, but it is associative. Yes, it what do you call it? Distributive property. Yes, the distributive property you can apply here, okay. Yes, it can be multiplied with identity matrix IA or AI. You will get always A. That means the multiplicative identity is I. What do we call it? Multiplicative identity is I is the square matrix in which you see all the diagonals 1 and except the diagonals you see all elements 0, okay. And array inverse, no, or yes. So okay, if AB equal to suppose 0, AB equal to 0 matrix, okay, this is a matrix, 0 matrix, so it is not necessary that A is equal to 0, it is not necessary B equal to 0 or AB equal to also 0, okay. It is not necessary that A is 0, it is not necessary, AB can also 0. So to support this question I can give you the example here. I have A equal to 0 0 minus 1 0, B is what? B is 1 0 1 0 1 0, and I have to remove this, okay. What will be AB and what will be AB here? So here you see A is not equal to 0 matrix, okay. B is also not equal to 0 matrix, okay. It is not equal to 0 matrix. But what about AB? If you want to find AB, 0 0 minus 1 0 and 1 0 1 0. The order is 2 cross 2. Check it, 2 cross 2. The order is 2 cross 2, and the column should be equal to the row here. The column of first matrix should be equal to the row of the second matrix, okay. So whatever what order you get, you'd get here in order 2 cross 2. That means if you multiply, you'd get the same what order? 2 cross 2, the left element, okay. Or you can say the n cross p, what? 2 cross 2. So here row 1 will multiply with column first. So 0 into 1 0 plus minus 1 into 0 0. Row 1 will multiply with column second. 0 into 1 0 minus 1 into 0 minus 1 into 0 0, okay. Row 2 will multiply with column first. 0 into 1 0 plus 0 into 0 0. Again row 2 will multiply with column second, it would be 0 into 1 0, and 0 into 0 it is 0. Okay, so in this case we see here that 0 0 0 0, and this is 0 matrix. Okay, null matrix. Okay, so it is not necessary that A is 0 or B is 0. AB can also 0 if A into B equal to 0. Okay, the product can be 0. So now move to the question here. The question is 1 minus 2 3 4 5 2 2 minus 3 5. Oh my god. So you have to find the value. So you see here 3 matrices are there. The first matrix has order, I think 1 2 3 3 rows and 3 rows and 1 column only. Okay, it has order 1 row and how many columns? 1 2 and 3 columns. Okay, so here how many rows? 1 2 3 3 rows, and how many columns? Only 1 columns. Only 1 column, not columns. Okay, now since you need to know that if it is A, B and C, suppose if it is A, B and C, so matrix multiplication is associative. So we can do first multiplication of first 2 matrix, then we multiply the answer with C. Okay, so we move like this. First multiply this and this. So here I have told you that you need to check whether the column number of first matrix should be equal to the row number of second. So here you see the result. Okay, 1 and is equal to 1. Then result would be in order 3 cross 3. The result means the AB, the product, will be in order 3 cross 3. Then you have to prepare with this. Okay, now what I have taught you, row 1 would be multiplied with column 1, row 2. Okay, this is column 2, this is column 3. Okay, this is C1, C2, C3, R1, R2, R1, R2 and R3. All right, now you move to the question. Okay, this is now row 1 will multiply with C1. So 1 4s are 4. Okay, 1 4s are, since in the column there is not another element. Okay, so you are bound to multiply only with 4. So 1 4s are 4. Okay, 1 5s are 5. Now row 1 multiply by second column. Okay, row 1 multiply by third column. 1 2s are 2. Okay, so here row 2 multiply with first column, minus 2 into 4, it is minus 8. Okay, row 2 multiply with second column, here minus 2 multiply by 5, it minus 10. Row 2 multiplied by third column, it is minus 4. All right, and similarly row 3 is 3 multiplied by 4. Okay, so it is 12. And row 3 multiplied by second column, 3 5 are 15, and row 3 multiplied by third column, it is 6. All right, this is the result, and it is in order 3 cross 3. And the C, what is C here? It is 2 minus 3 5. And what is the order? 3 cross 1. Now you are going to find the product, and what is the procedure? You need to check whether the column number here, the first matrix, should be equal to the row number of second. Okay, and the result would be in order the rest 1, 3 cross 1. The result would be order 3 cross 1. That means it would have 3 rows and 1 column. 3 rows and 1 column. All right, you need to check this. So this is this satisfies my condition. Now we are moving to that product R1, R2, R3. This is C1. All right, So row, we move to row first, okay, will be multiplied with column first. All right, how? 4 into 2 plus 5 into minus 3 plus 2 into 5, because in the column first there are many elements. That's why we are applying plus in between and multiplying and adding. And here 2 multiplied by 5. All right, minus 8, the row 2 will be multiplied with column 1, minus 8 into 2 plus minus 10 into minus 3 plus minus 4 into 5. Again row 3 will be multiplied with column 1, 12 into 2 plus 15 into minus 3 plus 6 into 5. Okay, so now the order is 3 cross 1 here. When you add solve this, you would get here 8. I have solved this question. 8 minus 15 plus 10, it would be 3, and you'd get minus 16 plus 30 minus 20, you'd get here minus 6, okay, plus 24 minus 45 plus 30, you'd get here 9. Okay, so this is the answer. Let's move to the next question, and this would be the last one. Okay, so I hope you have understood how you apply the practice. Is very important. If you do not do practice, then definitely you will not be able to, that means solve this. So let's move to the last question. The last question is A equal to cos square alpha sin alpha cos alpha sin alpha sin square alpha. All right, B equal to cos square beta cos beta sin beta cos beta sin beta and sin square beta all square. All right, are two matrices such that product AB is null matrix. Here it is given that product AB is null matrix, means it is null matrix. Okay, and then you have to find A minus B. What is this? A alpha minus beta, sorry, not A minus B. Find alpha minus beta. All right, so AB is a null matrix. Here the order A, what the order of A is 2 cross 2. How? 2 rows and 2 columns. Order of matrix B is 2 cross 2, same, 2 rows and 2 columns. Okay, 2 columns. AB is equal to 0, it is given here, AB. So let's multiply A and B. Okay, how would you multiply? You multiply, this is first row, this is column, first column. Okay, first row will be multiplied with first column. Okay, so how? This is R1, this is R2. Okay, and what about the order? We haven't checked the order. First, the column of first matrix should be equal to the row of the second matrix. Yes, it is equal. Now your answer would be in order to the rest one which I have not circled, the 2 cross 2. All right, now the answer would be in AB would be in 2 cross 2. So you have to prepare yourself, because it would be very okay. So let's move to the product. So how would you multiply? This cos square alpha would be multiplied with C1 first, the element of C1, and cos square alpha. What's cos square alpha? Cos square beta plus cos alpha sin alpha will be multiplied with cos beta sin beta. Cos alpha sin alpha multiplied with cos beta sin beta. Okay, again row 1 will be multiplied with column. Second, how? Oh my god, So cos square alpha, row 1 and column second. Okay, cos square alpha, cos beta, sin beta. Okay, cos square alpha, cos beta, sin beta, multiplied by cos alpha, sin square beta, plus cos alpha, sin square beta. Similarly, row 2 multiplied by column first. How? Cos alpha, sin alpha multiplied with column first, cos square beta. Okay, and sin plus sin square alpha multiplied with sin square alpha multiplied with cos beta, sin beta. And similarly, row second will multiply with column second. Here I have, anyways, cos alpha, sin alpha multiplied with cos beta, sin beta. Okay, and plus in between sin square alpha multiplied with sin square beta. So the multiplication is actually very now 2 cross 2 matrix, 2 rows and 2 columns. Here you see. Now we are at the end. When you take cos alpha, cos beta common, what would you get? Cos alpha, cos beta. You'd get cos alpha, cos beta plus sin alpha, sin beta. So there is a formula: cos A, cos B plus sin A, sin B. So what would you get? Cos A minus B, cos alpha minus beta. Okay. So here, when you take common, similarly when you take common sin alpha and sin beta, when you take common sin alpha, sin beta, what would you get here? Cos square beta. What? No. Sin alpha, okay. Cos alpha, what would you get? No. What is this? Cos alpha. No, cos alpha. Sin alpha, okay, common. Cos beta? Yes, common cos beta. Sin alpha, cos beta common. Sin alpha, cos beta, you would get here. Sin alpha, cos beta, you would cos alpha, cos beta, cos alpha, cos beta plus sin alpha, sin beta. Cos A, cos B plus sin A, sin B. Again, you will get here cos alpha minus beta. Okay. So I have solved this. So I am only writing this. So cos alpha, sin beta, you will get here. When you solve it, you will get cos alpha minus beta again, and sin alpha, if you take common here, sin alpha, sin beta, you will get again cos alpha minus beta. Okay. Order is 2 cross 2. Since it is actually equated with what? With 0 matrix, null matrix. So okay, null matrix is 0 0 0 0. Okay, the order is 2 cross 2. So we can equate. So this is equal to null matrix, it is given. So we equate this, the element of this, that means corresponding elements of the matrix AB can be equated with null matrix. Okay, so corresponding element is cos alpha, cos beta, cos alpha minus beta equal to 0. You can equate it. So when you equate this, so we can write the answer here. So cos alpha, cos beta, and what was that? Cos alpha minus beta equal to 0. Okay. So here we have to find the value of cos alpha minus beta. So take cos alpha minus beta equal to 0, means when you take cos inverse both side, cos alpha minus beta equal to cos inverse 0. So alpha minus beta would be, so here the cos pi by 2 is 0. Okay, cos pi by 2 cos 3 pi by 2. So you'll get here 2n plus odd multiple of pi by 2 as answer. So I hope you have understood. Thank you very much for watching this video. Thank you.